Hello, so in this video we will talk about the log normal distribution, and we will find the mean and variance of this distribution. So that, as by definition, a continuous random variable x is said to have a log normal distribution if its PDF is given by this expression. Okay, so this is e to the power of natural log x minus mu negative squared over 2 sigma squared, and then divided by x and then 2 sigma squared square root, and then the support is 0 to infinity. Okay, so specifically, if we have to find the mean, we will use these two tools. So first tool is that this integral, this guy, is equal to 1. This is because this represents the normal distribution here. And then the second thing is we will use the concept of completing squared. In other words, if we have an expression like ax squared plus bx plus c, we can write it as a times x plus b over 2a squared plus this expression c over a minus b squared over 4a squared. Okay, now let's proceed. Now, what is our mean? Our mean is 0 to infinity x fx x dx. So this is equal to plugging it here. So this x and this x will cancel out. So I can directly write 1 over root 2 pi sigma squared e to the power of negative natural log of x minus mu squared over 2 sigma squared dx. Okay, now let's make a change of variable here, because this guy I want to be a single variable. So what do we do? We say y is equal to natural log of x minus mu. Now if x goes from 0 to infinity, when x goes to 0, natural log of 0 is what? Minus infinity to infinity. Minus infinity. So what is natural log of infinity? Which is, we can say, infinity. So the limits of y are from minus infinity to infinity. Okay. And then we can say y plus mu, this is equal to natural log of x, which means that x is equal to e to the y plus mu. Okay. And then what is dy by dx? So dy by dx, this is equal to 1 over x. So I can also say that dx, this is equal to x dy. And what is x? X is this guy. So ey plus mu dy. Now let's put this guy in place of this guy. Okay. So now what is e of x? E of x is minus infinity to infinity 1 over root 2 pi sigma squared e to the power of minus y squared over 2 sigma squared times e to the power of y plus mu times dy. Correct? Okay. So then I can take what? I can take e to the mu out. I can also take this guy out. And I can say minus infinity to infinity e to the minus y squared over 2 sigma squared plus y dy. Correct? Now use this guy in place of this guy. So then if we have this story, so I can say this I can say minus 1 over 2 sigma squared y squared plus 1y plus 0, right? So then this guy is my a, this guy is my b, and this guy is my c. So I can just plug and play here. So this guy is equal to what? So I can say this is equal to minus 1 over 2 sigma squared. Now x, what is b? B is 1. So y plus, okay, 1 over negative 1 over 2 sigma squared. Correct? And then times 2, because we have 2a here. So times 2. Okay. So then this guy squared plus c over a, so plus 0, minus b squared, so 1 over 4a squared. So 4 times negative 1 over So negative 1 over 2 sigma squared. Okay, so this looks messy, but I think this will be easy to evaluate. So I can go here. So this is equal to minus 1 over 2 sigma squared. This is there. Then I can say this is what? This is uh, this guy is 1 minus this 2 cancels out with this 2. So minus 1 over sigma squared. So I can say y minus sigma squared. Okay. Then this guy is what? This guy, this 2 goes 2 times here. So I can say, and no. Okay. So here we have 2 squared, so 4. So this goes with 4. So this is sigma to the 4. So I can say sigma to the 4 and positive. So I can say minus sigma to the 4. Correct? Because this 4 will cancel with this 4 and this squared will make it 1 over sigma 4 and this goes up. Okay. So then this is my story here. So then I can go back to this guy here, this star here. So I can say this star becomes what? E to the mu 1 over root 2 pi sigma squared minus infinity to infinity e to the minus 1 over 2 sigma squared y minus sigma squared, and then I would say, and this minus this will become e to the sigma squared over 2, correct? Dx, sorry, dy. So this sigma 4 and this sigma squared will make it sigma squared. This minus and minus will become plus, and then this half is this half. Okay, so then I can do what? And I can bring this guy here. So I can say e to the plus sigma squared. Then 1 over root 2 pi sigma squared minus infinity to infinity e to the minus 1 over 2 sigma squared, and then y minus sigma squared dy. So comparing it with this guy, in place of this mu we have this sigma squared. This b we have 2 sigma squared, this b we have sigma squared, and then this b we have the sigma squared. So irrespective of whatever we have here, if as long as this guy and this guy are same, then we can say then this guy, and this should be sigma squared over 2, then this guy here, this is equal to 1. So this means that my mean is what? My mean is e to the mu plus sigma squared over 2. So this is the mean of my log normal distribution. Okay, so now let's talk about the variance here. So for the variance, we know that variance of x, this is equal to e to the x squared minus ex squared. So I can say e to the x squared minus this e, so I can say e to the 2 mu plus sigma squared. Okay, so I just have squared here, so this becomes 2 mu and this becomes sigma squared. Okay, now we have to calculate this guy, and we will see that it's the same thing as calculating the mean. We have to use the same two tools. Okay, so what is e to the x squared? So then we have 0 to infinity x squared fx x. Okay, now this fxx, if we go back to our definition, so this x squared will cancel, one of these x from this x squared will cancel out with this. So then I can write 0 to infinity 1 over root 2 sigma squared x times e to the minus natural log of x, sorry, minus outside, this is plus, minus mu squared divided by 2 sigma squared and dx. Okay, Now what do? We do the same story. We say y is equal to natural log of x minus mu. We have already seen that x is equal to what? E to the y plus mu. And we've also already seen that dx is also equal to e to the y plus mu times dy. And then the limits of y are from minus infinity to infinity. So minus infinity to infinity. So now then we do what? We just plug these things. So e to the x squared, this is equal to 1 over 2 pi sigma squared minus infinity to infinity e to the y plus mu e to the minus y squared over 2 sigma squared e to the y plus mu times dy, okay, which is equal to 1 over 2 pi sigma squared minus infinity to infinity, and then I can say e to the 2 mu I can take out, correct? I can say e to the minus y squared over 2 sigma squared plus 2y, and I can say times dy, correct? Okay, now again use this. Let's say this guy, this is minus 1 over 2 sigma squared y squared plus 2y. So comparing it with this guy here, so we say that, okay, this is my A, this is my B, and what is my C? My C is, I can say plus 0. This is my C. Okay. Okay. So then this guy becomes what? I can say minus 1 over 2 sigma squared. This is my A here. So then my first term is what? Y plus what is B? 2 divided by 2A. So 2 times negative 1 over 2 sigma squared plus C over A plus 0 minus B squared, which is 4 divided by 4A squared. So 4 times minus 1 over 2 sigma squared. Okay. Okay. Now we have to simplify. So what is this guy? This guy is what? So this goes with this. And I have a minus 1 over sigma squared. So I can say y minus 2 sigma squared. So this is equal to, so I can just copy this guy. So I can say y minus 2 sigma squared plus 0 goes. So this 4 goes with this 4. And then I have what? This is what? This is 1 over 4 sigma 4 with a positive. So I can say this becomes 4 sigma 4. Correct? So then I can also say this guy is equal to minus 1 over 2 sigma squared y minus 2 sigma squared plus, now this 2 goes 2 times, so 2 sigma squared. Okay, so now going back to this guy here, so I can say this becomes e to the 2 mu, and then this 2 sigma squared I can say plus 2 sigma squared, then 1 over root 2 this, then minus infinity to infinity. So this is e to the minus 1 over 2 sigma squared y minus 2 sigma squared dy, right? So what do we say by this story? This is exactly the same as this story, because we have here 2 sigma squared and here we have a sigma squared. So this guy, this is equal to 1. So I get e to the 2 mu plus 2 sigma squared. So what is the variance? So variance of x, this is equal to e to the 2 mu plus 2 sigma squared minus this guy minus e to the 2 mu plus sigma squared. Okay, so if you want to simplify, you can simplify again, but you don't have to. 2 mu plus sigma squared, and you can say e to the sigma squared minus 1. So this is another way to write it, but for solving purposes, this is good. Okay, but this is also written sometimes. Okay, so this is it about finding the mean and variance of the log normal distribution. And what we make repeated use of two facts. One is this integral is equal to 1, and the other is the so-called completing square method when we have a quadratic equation. Hope it was easy to understand, and thanks for watching. Hope you liked the video.